Hi, I'm Palazoglu. I'm a senior computer engineering student at Bogazici University, and this is distributed stream processing on edge cloud systems. Our motivation for this project is that cloud computing cannot keep up with increasing demands of real-time IoT and their stream processing applications. So edge cloud paradigm is being used instead. Some issues include network latency, network bandwidth, and lack of a proper testbed for edge cloud applications. Here we see a typical scenario that illustrates network latency of physical node topology. We use RiotBench, a distributed stream processing engine benchmark, which is written for Apache Storm for our testing environment. It also helps that RiotBench is widespread in related academic work, and it is focused on IoT applications, which makes it suitable for edge cloud systems. Apache Storm is the distributed stream processing engine we use. It is open source, but not designed with edge cloud in mind, and we needed to modify it to make it map operators to nodes as we desire, which we call placement enforcement. Placement enforcement means restricting the mapping algorithm in Storm to send edge-related operators to edge hardware and cloud-related operators to cloud hardware. Original Storm scatters the operators without any restrictions and tries to find optimizations early, which sometimes fail. We need a testbed to test the benefits of using edge cloud approach in certain applications. We decided to go with CORE Network Emulator. CORE Network Emulator enables various network restrictions to be imposed on the distributed system, such as network latency of links, bandwidth, packet loss, etc. With this, we can evaluate effects of these parameters on our system realistically. To draw our graphs, we use graphite. It is reported in real time, such as you would do in a real-time running application. We report full process time of tuples generated at the source. And full process time means a tuple and all its tuples in its tree, meaning the smaller tuples it gets split to, are processed. Here we see how the full process time comparison looks like when cloud-to-edge network latency is 5 milliseconds. There is no dramatic difference, but in general, edge cloud is better. After 40 milliseconds, we see that edge cloud is distinctly better in all stages of the experiment. At 80 milliseconds delay, we see a dramatic difference between edge cloud and cloud-only system. Here is the full process latency comparison of cloud-only with increased network latency. And here's the same graph with edge cloud system in mind. So, in conclusion, we can see the positive effects of including edge hardware on latency of computation on DSP applications. And we have a flexible testing and experiment setup thanks to CORE Network Emulator. And we can use cloud experiment services such as Cloud Lab with the modified Storm to test edge cloud applications and get data via graphite. Thank you for listening. This is all.